Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some explanations just feel simpler and more, right? Even if there might be other possibilities out there. Well, this new study dives deep into that exact question. Imagine you are trying to understand why something happened. You've got a few possible explanations, right? Some are straightforward, pointing to one main reason. Others are more complicated, involving several different factors working together. Most of us tend to lean towards those simpler explanations. But why? And does this preference always lead us to the truth? Or does it sometimes lead us astray? This research paper looked into that very idea. Think about it this way. If your car won't start, is it more likely that one single thing went wrong, like the battery, or that 5 different things all failed at the exact same time? Your brain probably jumps to the single cause. Scientists call this a simplicity bias. We like simple and we sometimes like it too much, even when the numbers might suggest otherwise. The big question this research tackled is where this bias comes from. There are two main ideas about why we like simple explanations. One popular idea, coming from math and statistics, is that simpler explanations are often more likely to be true. This is called the Bayesian perspective. It suggests that we use the simplicity of an explanation, like the number of causes it mentions, as a clue to how probable it is. So, an explanation with one cause gets a kind of boost in our minds because it is simpler and likely more probable. But there is another way to think about it from something called compression. Imagine you are trying to describe something. A simpler explanation is like a shorter, more compressed description. It is easier to grasp, easier to hold in your mind, and easier to process. This perspective suggests that we might prefer simple explanations not just because they're likely true, but because they're cognitively simpler, easier for our brains to handle. This is called a compression-based account. This research wanted to see which of these ideas, the math-based Bayesian view or the brain processing-based compression view, better explains why we favor simple explanations and why we sometimes get it wrong. So, how did they test this? They designed studies where people had to judge explanations for certain events. In these scenarios, there was a simple explanation with just one cause, and a complex explanation with 2 causes, but both could explain the same observed effects. They gave participants information about the probability of each individual cause actually occurring. Using this information, they could mathematically calculate the correct prior probability for each explanation, that is, the probability before you even consider the specific effects you are trying to explain. They also looked at posterior probabilities, that is, the probability after you consider the effects. In study 1, they looked at how people naturally felt about the ease of understanding these explanations. They found that simpler explanations were indeed usually seen as easier to understand. And here is the key: the more people found the simple explanations easier to process, the stronger their simplicity bias was, especially when they were judging the posterior probabilities, how likely something is after seeing the evidence. This is super interesting because it suggests that it is not just about the number of causes in an explanation, but how easy it is for our brains to process that explanation. If a 2-cause explanation feels harder to wrap your head around than a 1-cause explanation, you are more likely to favor the simpler one, even if the probabilities should theoretically make them more equal. What is also fascinating is what happened with the prior probabilities. In some cases, when people were judging the prior probability before considering the effects, they actually showed a complexity bias, meaning they thought the more complex explanation was more likely, or at least not less likely than the simple one. This is the opposite of what you'd expect if simplicity was always boosting prior probability. The researchers think this might happen because people sometimes miscalculate joint probabilities, that is, the probability of 2 things happening together. Study 2 took this a step further by manipulating how easy the explanations were to process. They changed the wording of the scenarios to make the complex explanations clearer, or they gave people multiple practice trials to become more familiar with the types of explanations. And guess what? When the explanations were made easier to process, the simplicity bias in the posterior judgments decreased or even disappeared. This is strong evidence that cognitive ease, not just the number of causes, is driving these biases. It is like our brains are saying this is easier to understand, so it must be better or more likely. Study 3 looked at why people use ease of processing. They found that people used it in 2 main ways. Some used it as a signal that an easier explanation was more likely to be true, that is, an accuracy-based reason. Others valued ease of understanding for its own sake, because cognitive efficiency is just a good quality in an explanation. Regardless of its probability, that is an efficiency-based reason. So what does all this mean for us? It tells us that our preference for simplicity in explanations isn't just about logic or pure math. It is deeply tied to how easy our brains find it to process that explanation. When a simple explanation is easier to understand, we tend to favor it, sometimes to a fault. This can lead us to overlook more complex but potentially more accurate explanations. The other really important takeaway is how these biases often happen after we've considered the evidence directly in our posterior judgments. This is hard to explain with the traditional Bayesian view, which focuses on how simplicity influences our initial beliefs. But it makes a lot of sense if processing difficulty is the culprit. When we're trying to connect causes to effects, especially for more complex explanations, our brains have to work harder, and that effort can color our final judgment. This research also points out that sometimes what looks like a simplicity bias might actually be due to misunderstandings or miscalculations. For example, in some older studies, wording like never causes might have confused people about how likely an explanation was, leading them to favor simpler ones, not because of simplicity itself, but because they misunderstood the rules. So, what are the strengths here? The researchers did a fantastic job of trying to isolate different factors. They kept the number of causes the same while manipulating how easy the explanations were to understand. They also gave us insight into why people use ease of processing. This helps build a more complete picture. What about limitations? Of course, these studies used simplified scenarios. Real-world explanations are often much messier and involve more social context. The paper does touch on this, noting that in communicative context, complexity can sometimes signal expertise, which might change how we feel about an explanation. In the end, this study offers a really compelling argument that our biases towards simple explanations are often driven by how easily we can process them. It's not just about the number of causes, but about the mental effort involved. This highlights how our cognitive processes, the way our brains work, can quietly shape our judgments, sometimes leading us to prefer the easy answer over the potentially more accurate, but harder one. This is super important to remember when we're trying to make sense of the world around us and when we're evaluating the information we encounter every day. If you found this breakdown helpful, please give this video a thumbs up. Leave a comment below with your thoughts on simplicity biases. And don't forget to subscribe to RUBIN'S Mind Lab for more dives into the fascinating world of psychology. Thanks for watching, and I'll see you next time.